Yes, very good morning to everyone. In this video, we are going to discuss about what is divide and conquer, what is binary search. So those things we will going to discuss in this presentation. So first, we need to discuss about what do you mean by divide and conquer. As its name implies about the definition, divide means break, conquer means combine the solution. So divide and conquer means it can be applicable for solving large size of computational problem. Large size of computational problem means that if I have a computational problem with large size, let me assume that the size of the problem is n. Let me assume that the problem P with size n means I can divide the problem into subproblem and each subproblem will be solved individually. Then the solutions of all the subproblem will combine together to give a solution for the main problem. This is the concept behind this. In this case, if the problem size is small, then we need not have to apply divide and conquer strategy. And if there is no mechanism for combining the solutions of all the subproblem, then also we need not go with this divide and conquer method. Algorithm, method, strategy, all are equal. So now let us have a brief discussion about this divide and conquer. As I said before, divide and conquer is an approach to solve any computational problem. Let me take the problem P with size n, then I can divide the problem into subproblem like P1, P2, P3, etc. Pk. Then the solutions of all the subproblem will combine together to give a solution for the main problem. In this case, if the subproblem is also large, for example P1, P2, P3, etc. Pk, the size of all the subproblem is also large, then again we need to divide the subproblem into subproblem. Then we have to find out the solution, combine together. Then the solutions of all the subproblem will be combined together. That will be the final result of the main problem. This is the concept behind this. Then next one is that is whatever be the problem, the subproblem is also must be like the main problem. For example, if I am going to perform a sorting operation for a particular problem, then for that if the size is too large, then I have to divide the sorting algorithm into subproblem. In those case, the subproblem is also must perform the sorting operations alone. Instead that it should not perform any searching operations or any other operations. The subproblem also must perform the same sorting operations. And one more real life example I want to say. I am going to organize one conference or workshop or anything. So in those case, if the event is going very lengthy of time means I can break the event into sub events. That is, in a different venues I can allocate for the participant to present their paper or some other things. For conference means all the research scholars or research experts might present their innovative idea in terms of paper. So those cases, the conference, if the conference is going to be held for lengthy time means I can break the system into different venues. That is, for a particular area I can allocate one room, another particular research area I can allocate another room, and so on. Instead that I should not divide the problem into another problems. For example, conference paper presentation means the sub event also must be like paper presentation. The sub event should not conduct any quiz or any other online competitions and all. Whatever be the main problem, then the subproblem is also must be alike the main problem. That is the concept behind this. Then if the problem is the subproblem must have a solution, and we must have a technique to combine all the solution, otherwise we cannot go with this strategy. So this is the concept behind this. And next one is consider this example. DAC stands for divide and conquer. P stands for problem. I am going to apply divide and conquer strategy for a problem P. So if the problem size is small, then I can find a solution. Otherwise, I can divide the problem P into sub-problem, then combine the solution of all the sub-problem. I'll have a solution for my main problem. This is the concept behind this. Then next, divide and conquer can be applicable for binary search, finding maximum and minimum, merge sort, quick sort, Stresham's matrix multiplication. So for the above, we need to discuss about how to find recursive algorithm, analyze the algorithm, and time complexity. Recursive algorithm also we discussed in the earlier module. Analyze the algorithm also we discussed earlier, and time complexity also we discussed earlier. Based on all those techniques, we are going to find out everything for all the algorithms. Then binary search. Before discussing in detail about binary search, we should know what do you mean by searching. Searching means identifying any element's existence in the array. That is called as searching. For example, I have an array. Before discussing about those things, we should know what do you mean by array. Array means it is a collection of different elements with the same data type. For example, integer array means I can hold all the integer data elements alone. I cannot have some elements are integer data type, some elements are float data types. It's not at all permitted. So all the elements in an array should have same data type. So assume that I have an array with a size 10, which means that I can have I can keep 10 number of elements in an array. So let me assume that 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Now I am going to search an element 50 from this array. I can perform two different kind of searching operation. Searching operation means to check whether the given element is present in the array or not. Now I am taking the element 50. Here 50 is a key element. So using that key element 50, I am going to make the searching operation in the array. So now I can go search the element in two different techniques. One is linear search, another one is binary search. Before performing searching operation, we must assure that all the elements in the array must be in a sorted way. That is either in ascending order or in descending order. If it is elements, it can be either in ascending order or in descending order. Alphabets means as per the alphabetical order, it must be arranged. Then only I can go with binary search. It's a very, very important thing. Whenever I am going to perform any searching operation in an array, it must be sorted out. Otherwise, I have to apply sorting algorithm over an array. Then after all the elements have been sorted out, I can perform searching operations in an array. So now, as I said before, there are two different kind of operations I can perform over the array. One is linear search and another one is binary search. Linear search means, as I said, that 10, 20, 30, etc. 100 elements are present in the array. So linear search means my key element is 50 here. I have to map my key element with the first element. 50 with 10. Is it equal? No. Then I have to move ahead. 50 with 20. Is it equal? No. Likewise, I have to keep on searching every element one by one until I am identifying the corresponding element in the array. In this occasion, we must know that if the element is not present, then it will not map anything on the given array. So this is a very time consuming process. So to overcome this time consuming process, I am moving with binary search. Binary search is very, very simple. Since we are going to divide the number of elements in the array into 2, then I'll make search in one particular part of the elements. If it is present, then I will identify, then I will bring it into the notice. Otherwise, I will search the element in another part of the elements. So for those case, as I said before, all the elements in the array must be in sorted way, sorted. Then only I can go with binary search. In this case, the first element, the very first element, I should have to mark it as low. At last element in the array should be marked it as high. Now I have to find the midpoint. The midpoint will be calculated as low plus high by 2. For example, if 10 number of elements or 11 number of elements are present in the array, first elements in the array will be marked as 1. Last element will be marked as 11. So 1 plus 11, 12. 12 divided by 2. 6 is the middle element. So the 6 is middle element. I have to check the position, sixth position element with my key element. If my sixth position element is equal with the key element, then I can confirm that the element is present in the array. Otherwise, if my key element is less than the mid element, then I have to search the element, the left hand side part of the mid element. How can I search the left hand side part of the mid element? Means in those situations I have to keep my low element as it is, low value as it is, but the high value I have to decrement it by 1. Okay. And another case, if my key element is greater than the mid element, in those case I have to keep my high value as it is. I have to increment my mid value by 1. That is the main concept. If it is less than means I have to keep my low element as it is. Mid value has to be decrement by 1. If it is greater than, then I have to keep my high value as it is. Mid value has to be increment by 1. This is the concept behind this. Then I have to keep on search the same. I have to repeat the same process until I am identifying the corresponding value. In those case, if my high value is less than the low value, high value is less than the low value, then we can assure that the number is not present in the array. This is the concept behind this. So next, let us look at this algorithm. Algorithm A stands for array, N stands for number of elements present in the array, key means the element which we are going to search in the array. As I said before, low will be 1 and h will is equal to n. I am checking out middle, that is later we will use while loop. Mid value will be computed by low plus h by 2, and I told you that if mid value is equivalent to key, then it will return mid. Otherwise, if the mid element is less than key, mid value will be increment by 1, then it will be returned. Otherwise, h value will be decrement by 1, then again mid value will be returned. This is the concept. This will keep on repeated until the low value become less than high. If low value becomes greater than high, then we can share that the number is not present in the array. So this is the concept behind this. So for this case, as I said before, we need to find out some complexity over here. So when we discussed about recursive function in the previous module, so binary search LH key or the parameter. So whatever be the function, it will need to be marked as T of n. Then if L is equal to H will require 1 unit time. Then I am checking out. So in this case, recursive algorithm means one important thing, that is, this is another kind of method which we are applying for binary search. So now binary search is very simple compared with the linear search, because in linear search we have to keep on searching every element, but in binary search is not like that. Simply we can divide and we will make a searching operations over here. So assume that in an array only one element alone present. If there is only one element, then both low value and high value will be equal. So for that case I am specifying if L is equal to H. So in this case, if A of L means the number which is present in the array is my key element, then I can return the same value. Otherwise, what I have to do, I have to find out mid value as like L plus H by 2. If my mid value is less than key, then I have to return as I said that mid value will be increment by 1, H value will be as it is key value. Else if mid is greater than key value, then I have to keep my low value as it is. Mid value will be decrement by 1, then key value need to be passed. So if it is not present, then it will return 0. So now I am going to tell you how to find out the recursive functions for this. So as I said before, always function will be t of n. So this is marked as t of n. If L is equal to H, if A of L is equal to key, return L, everything will require only 1 unit time. So 1, 1, 1 we can use, no problem. Then the calculation part, if mid is equal to L plus H by 2, that is also will require 1 unit time. Then if mid less than key, required 1 unit time. Then again return binary search mid plus 1 comma H comma key, required 1 unit time. Again one more if statement, require 1 unit time. Then return L comma mid minus 1 comma key. This will, because in both there are two different cases we are using mid value. One is mid plus 1, another one is mid minus 1. Mid is calculated as L plus H by 2. So that's what I am using n by 2. Mid value is passed 2 times. So I am using 2t of n by 2. When I add up all those things, I'll get the corresponding recursive function value. So t of n is equal to 2 times t of n by 2. This is the recursive function. So we can solve this by repeatedly replacing the n by 2 value by another n by 2. At last the algorithm will complete one finite amount of time, let it be k. So at k time we have to replace n by k, then we will find an answer. So this is the concept behind this. So whenever I am taking the algorithm parameter as t of n is equal to 2 times t of n by 2 plus 1 when n is greater than 0. When n is equivalent to 0, it will be 0 only. But time complexity will not take 0 value. So it is represented as 1. So this is the concept behind this. The remaining things we will discuss in the forthcoming video. Thank you.